Welcome, class. Today your lesson is called Polynomials, and this just stems right from monomials, which we have been working with previous to this. A polynomial is a monomial, or the sum of monomials, each called a term of the polynomial. Some polynomials have special names. You can have a binomial, which is the sum of two monomials, or a trinomial, which is the sum of three monomials. And of course, that means you can see subtraction in the problem too when they say sum. And here is a table showing us some of these examples. So here's your expression, 4y and a negative 5xc. This is a polynomial because it's the sum of two monomials, 4y and negative 5xz. So you call this a binomial because there's two. The next one is a polynomial because negative 6.5 is a real number. It's a constant. So it's a monomial because there's only one term. C, this one is not a polynomial because you would rewrite a to the negative 3 on the bottom. You would take it to the denominator, and that puts a variable in your denominator, which is not a monomial. So it's none of these. And then letter D, you've got your 4x here and your x. Those are like terms. So you can put those together and make 5x. So then you'd have 1, 2, 3 whole terms, and that's the sum of three monomials, which is called a trinomial. And that is what you're going to be doing on the first part of your paper. And it'll look something like this. So the first one is a term. That's a monomial. The next two are like terms. They could be put together to make a positive 2y. So here's our second term, and then negative 1. So we have three separate terms when we're finished. So yes, this is a polynomial, and it's actually a trinomial. So you have to name it. Okay, the next one. Well, we have x to a negative 4. Well, we'd have to rewrite that to put it 10 over x to the 4th, which means no, because you cannot have a variable in the denominator. So this is none of these. It's not a polynomial or a monomial or a trinomial or a binomial. All right, the next one, 1/5 y to the 3rd. There's a constant in the denominator. That can happen. So there's a term. Then we have y squared, another term, and then negative 9. And all three of these are different because y to the 3rd and y to the 2nd are not like terms. So since we have three separate terms, this is, yes, a polynomial, and it's a trinomial again. That's kind of what you're looking at. Look at a couple more, or three more. Give you a look at all different types of examples. All right, in this one we see 7a squared b, 3b squared. These two are totally different because one has an a, one doesn't. So those are not like terms. And then a negative a squared b. Well, that's the same as the first a squared b. So this is like 7a squared b. Take away 1a squared b, leaves 6a squared b with a positive 3b squared. So we have two terms. Once you combine any like terms you see, you're left with two. So this is a binomial. And yes, it is a polynomial, of course, if we're calling it a binomial. Okay, a constant, a single term is yes, but this one is a monomial because it's one term. Whoop. If I can spell it right, monomial. All right, and then the last one. Again, we have a variable in the denominator. So no, none of these, because you cannot have a variable in the denominator. If you look back up to the middle one, this 10x to the negative 4, you also have a variable as an exponent. And that's another reason that can't happen either. All right, let's go to the next section that you're going to see, the degree of a polynomial. Now, these are kind of easy, but you got to understand what it's saying. The degree is the greatest degree of any term in the polynomial. Now, I don't know what a degree is. Let me keep going. The degree of a term is the sum of the exponents of all its variables. So all you're going to do is look at the exponents of the variables and add them up. A non-zero constant, that means any whole number that doesn't have a variable, has a degree of 0. So you won't factor that one in. So let's look at an example. I'll show you what I mean. The first term here has x squared and y 1. Well, if we add those together, the degree of this term is 3. Then the next one has x1, y3. We add those together, we have degree of 4. And then the last one, x squared, is just a degree of 2. So which one is the largest is the 4. So the degree of this polynomial is 4. You take the largest, the greatest degree is what you name it. All right, the first one, we have R2, T2, so that's a 4, degree of 4. R1, T2, that's a degree of 3. And then R3, T2, that's a degree of 5. The largest then would be 5. And there's our overall degree of that polynomial. If you had like a whole number like plus 3, you would just disregard it because we're going to assume we're going to use a 0. So it doesn't add in, it doesn't factor in at all. We're just looking at variables. Okay, the next one, N3M, that would be a degree of 4. M3 is a degree of 3. 2 and 4 make 6, and then another 2, so our largest is a degree of 6. I know you're going to think this is so easy. Okay, there's a 1, and it is, it really is. There's a 4, there's a 2, there's a 3, largest degree is a 4. And these are actually kind of fun because they are so easy. Okay, last part of your assignment, standard form of a polynomial. You're going to rewrite them in standard form. Now the standard form is written with the terms in order from the greatest degree to the least degree. Well, you just found out how to find the degrees, so then this makes this really easy. Now the leading coefficient is the coefficient of the first term. So that's just some vocabulary for you. Is we're going to list the leading coefficient and put it in standard form. So first name your degrees. The first one here has a degree of 2. This one has a degree of 0, and this one has a degree of 5. The largest degree is the positive x to the 5th. So we'll start with positive x to the 5th. Then we come over here to the 8x squared, and it's positive 2. 8x squared, and then the minus 15 goes at the end. Now, that's standard form. We have our greatest degree first, and it's in descending order. Now, the leading coefficient, we also have to put in our answer, because that's part of our instructions, is the coefficient of the first term. That's your number right in front of your variable, and this time it's a 5. Remember, that's the leading coefficient, not necessarily the degree. Happens to be the same this time, but it won't always be. All right, so here we go. Next problem. We've got a degree of 1, a degree of 0, a degree of 4, a degree of 3. Largest degree is our x to the 4th. So we start there, and it's a positive. Then we're going to have positive 4x3 as our next degree, and then a positive 10x, and then the negative 7 at the end. So I rewrote it, standard form. My leading coefficient this time is an understood 1. There you go. There's your 2 answers. We're going to do a couple more, and that's going to be the end of this lesson. Okay, this one, degree of 2, degree of 0, degree of 3, degree of 1. Biggest one is this positive 6x3. Of course, I didn't need the positive in front. But then we have a positive 13x squared. Then we have a negative x. And then we have a negative 5. Our leading coefficient, 6. There we go. One more example. Degree of 1, degree of 5, degree of 3, degree of 0. This one here is our biggest, so it's a positive 2x to the 5th. And we have a negative 6x to the 3rd. Then we'll have a positive 4x. Then we'll have a positive 2. Our leading coefficient is a 2. And that's your assignment, guys. I think you're going to really enjoy this and fly through it. It's really fun and really easy. I'll see you in class.